Okay, so I'm going to be going over this review for you guys for the test that is tomorrow. So let's go ahead and get started. I'm going to try to go through it not fast, but I don't want to take up too much of your time. So it says if the spinner below is spun once, find the probability of it landing on a dotted space. Well, let's count how many dotted spaces we have. 1, 2, 3. We have 3 dotted, right? Okay. So we have 3 dotted. Let's count how many we have in total, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 total slots. Because remember, the bottom number is always the total number that you have, the total amount of outcomes you could have. So in this case, it's 12. And then we said we had 3 dotted, right? Because that's what we're trying to find, P of the dots. So we're left with 3 over 12. Does 3 and 12 have anything in common? When you write the multiples of 3, obviously 12 is in there, right? So we know that both of these can be divided by 3. And when you do that, you get 1 over 4. And so the probability that you would get a dot out of the total number is 1/4. Because there's 12 total, and out of those 12 total, there are 3 that are dotted, and that's what we're trying to find. Okay. If the spinner below is spun once, find the probability of it landing on a stripe or a letter. Okay, the picture's over here. So a stripe or a letter is what we're trying to find the probability of. So let's go ahead and count the spaces that we have total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 again, it's the same spinner, right? Okay, let's count how many stripes we have. We have 1, 2, 3. Let's count how many letters we have. So we have 3 of those. Let's do 4, 5, 6, 7, 8, 9. So because we're finding either stripes or a letter, you just combine how many you have. So we had 3 of the stripes, and then we have 6 of the letters, right? 1, 2, 3, 4, 5, 6. 6 plus 3 is 9. And so what do we know about 9 and 12? We write the multiples of 3, 9 and 12 are on there, right? So let's divide this by 3, and we are going to get 3 over 4. And so the probability that you would get a stripe or a letter is a 3 out of 4 chance, right? Hope that makes sense to everybody. All you do for these is just get the total number on the bottom, count all of them, and then count what they're asking. Here, they're asking for stripes or a letter. So that means either or. So I counted the stripes, which is 3, and then I counted the letters, which is 6, added them together to get the 9. Now, if it would say stripes and a letter, so they're saying you need to have a letter and a stripe. Well, none of these, any of the letters don't have stripes though, right? So that's not a real good example for this one in particular, because that can't happen. The probability would be 0 because there is not a letter with the striped pattern, right? So, but the key word is that or though. So you add them together. Okay. This says a card is drawn at random from a standard deck. What is the probability that is a black card and a king? So 2 things. It has to be black and it has to be a king. And right here on the test, I'm hoping it shows up. I just put a like standard image of a deck of cards. But we know we have 13 hearts in a center deck. We have 13 diamonds. We have 13 cannot draw a club. And then 13 spades. I can't draw a spade either. So we have 13 of each set. Out of the hearts, diamonds, spades, and clubs, only the clubs and the spades are black, right? These are red. So those can't be there. And in every suit, you have, and then you have the numbers, right? Okay. So for every suit, there's only one king. So that means there are two black kings, right? One is a spade and one is a club. So since there's only two cards in that entire deck, that is a black card and a king, the total number, remember the bottom number is the total number. A standard deck of cards has 52. Remember that number. 52 is what goes on bottom. So total number of cards is 52. Out of those 52, only two of them, again, is black and is a king. It has to meet those two conditions. Because it says, this is what I was talking about, that keyword, and. Here, we can pick either or, a letter or a stripe. Here, it has to be both. It has to be black and it has to be a king. So 2 out of 52, what do we see about those? They're even, right? Let's divide by 2. And we are going to get 1 out of 26. And so it's that answer right there. Really hope this makes sense. At any point something doesn't make sense, write that problem down and message me and say, hey, can you try to explain this a little different or something like that, okay? Okay, this says a standard die is rolled 100 times. The results from the experiment are shown in the table below. Okay, so this is the theoretical probability and the experimental probability. So this says which correctly gives the theoretical probability. So what should happen? What would we think would happen? Of rolling a number greater than 4. So it doesn't say 4 and greater, it says greater than 4. So the only number on a standard, these are the numbers that are on a standard dice, right? 1 through 6. So the only numbers that are greater than 4 is 5 and 6, right? So let's count the total number. Obviously it's 6. We can only get 6 numbers. If we roll a die, there's only 6 numbers we can get. So that's the total number. And out of the total number, the odds of us getting a number greater than 4 is 2, right? A 5 and a 6. And again, what do we see about these numbers? They're even, right? If you write, you know, the multiples of 2, we see 2 and 6. So 1 over 3. That is the theoretical. That's what we think should happen. That is what we think would happen. Out of the 6 numbers you can get when you roll the dice, the odds that it is a number higher than 4 is only 5 and 6. So 2 out of 6. And that simplifies down to 1/3. And this one down here is the actual experiment, right? So give the experimental probability. Well, they already said, and it's still greater than 4. Which one's greater than 4? And that's only these two, right? We've already said that. And they told us at the beginning of the problem that they rolled it 100 times. So that is the bottom number. That's the total number of times they rolled it, is 100. And if you add up, the frequency is how many times the die landed on this certain number. So when they rolled it, they landed on 1 14 times. They landed on the number 2 23, the number 3 15 times, so on. So if you add these numbers up, you're going to get 100, but they already gave you that. So 100 is the total. And rolling a number greater than 4, remember 5 and 6. And so we need to add this 20 and 16. We need to add that because that's how many times it actually landed on those numbers when they did the experiment. And when you add 20 and 16, you get 36. What do we see about the numbers? Because obviously this isn't an answer choice. If you get, like here, if you get an answer, what you think is the answer, but it's not an answer choice, see if you can simplify it by dividing by 2, 3, 4, 5. See if you can divide both numbers by the same number to get even numbers. So here, this number obviously isn't on here. So what do we see about the numbers? Well, they are even. So let's see what happens. Let's just divide by 2, right? Let's just see. That's 18 over 50. Still, again, even numbers, right? 18 and 50. I guess we'll divide by 2 again and get 9 over 25. 9 and 25, do they have anything in common? Do they have a 3 in common? No, 25 does not divide 3. So I think we're good, right? Oh, and look, that's an answer choice. So, or if you saw that you could, 36 and 100 can both be divided by 4 evenly, and you see it actually went ahead one step, gave us our answer. But again, if you can't think of that number, just divide by 2 if they're even numbers. So how we got this again is this is the actual experiment numbers. Remember, this is just what we think would happen. This is what actually happened. Total number is 100 because they said they rolled it 100 times. If they said they rolled it 200 times, you would write 200 right there. Greater than 4, we already said it's 5 and 6. So you need to add those frequencies up. How many times did it land on those numbers? Add them together and then simplify, right? Okay. Next question. How many different outfits consisting of a pair of pants, a shirt, and a tie can be made from 4 pairs of pants, 7 shirts, and 5 ties? So they have 4 pairs of pants, 7 shirts, and 5 ties. And they want me to tell them how many different combinations of outfits can you make from having the set number of items. To find that is actually really easy. You simply, so they have 4 pairs of pants, they have 7 shirts, and they have 5 ties. All you do is times those numbers by each other. So they can make 140 different outfit combinations with 4 pairs of pants, 7 shirts, and 5 ties. Now you can draw this out. I mean, if you want to, here's the pairs of pants. I'm gonna draw, name this 1, 2, 3, 4. Draw the shirts and match them up yourself. But That's way harder. It's going to take you a very long time to draw that diagram. So the easiest way is just simply times the numbers by each other, and you will get the answer, 140 outfits. So let's take that same thing and let's try this problem. A company gives the client a unique account number containing 4 letters followed by 3 digits. So, how many account numbers are possible? Okay, so 4 letters and 3 digits. So, how many letters are in the alphabet? Because they can get any letter, right? How many letters can they get? There's 26 letters in the alphabet, right? So, and they said they were going to give them 4 letters. So we need to times that 4 times. So they're going to give them 4 letters. There's 26 letters in the alphabet. You can get any of them, right? So that's why we're doing that. And then numbers. Let's think about it. There's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because then when you go to 10, that's just a 1 and a 0, right? We've already counted those. So there's 10, and I'll write this 1, 2. And again, when you get to 10, we already have the 1 and the 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's a total, a possibility of 10 numbers they can get. And they said they were going to do that 3 times. They're going to have 3 digits. So times by 10. So we have our 4 letters and we have our 3 digits. Let's times these numbers, and we already see the answer choices, right? So we know it's going to be a big number. Big number, right? But we see that answer choice. Really hoping those are making sense. You simply just times, like here, we times the number how many they said they had to find the combinations. Here, we kind of had to do a little bit more work. You know, they said 4 letters and 3 digits. So we have to think, all right, how many letters are in the alphabet? 26. Times that by 4, because it said they were going to give 4 letters. And then same for the digits. Think about the digits. 10 doesn't count, right? Because there's already a 1 and a 0. So 10 digits 3 times, and we got that. Hope that we got that. Okay. This says a pop quiz contains 5 questions, 2 multiple choice with 4 options, and 3 true or false. And we know true or false obviously only has 2 choices. So it says, if Brad randomly guesses what is the probability that he gets all 5 answers correct? Let's think about that. They said there was 2 multiple choice with 4 options. So 2 typical multiple choice options. So if you think about it, he has a 1 out of 4 chance to guess that answer correct, right? 4 answer choices, 1 of them is correct. So he's going to have a 1 out of 4 chance of getting that answer correct on that multiple choice, right? Well, they said there was 2 of those. So let's times that again. So these are the multiple choice. He has a 1 out of 4 chance because there's only 1 correct answer, right? Okay, and they said there were 3 true or false. Now, true or false. You have a 50-50 chance, right? 2 answer choices, 1 are right, 1's wrong. So you have a 1/2 chance, a 1 out of 2 chance of guessing right. And they said there were 3 of those. So 2 multiple choice, 3 true or false. When you times those numbers together, which you can do this on a cell phone, just is going to look a little different as putting it in. Or you can go for your test during it, you can go to desmos.com. They have a scientific calculator on there. You can type in Desmos scientific calculator and it will come up with a scientific calculator. And we get 1 out of 28. Is that an answer choice, guys? Can it be simplified or anything? No. And that's that. So just took the odds of you getting the answer right out of one question, 1 out of 4 for multiple choice, right? You know, you always hear teachers say, just guess. You have a 1 out of 4 chance of getting it right anyways. So 2 of those, and then true or false, you have a 1 out of 2. So 3 of them. Okay, next question. If the standard die is rolled twice, find the probability that it would land on an even number, then a number less than 5. Okay, so let's take this part by part. It says find the probability that it would land on an even number. Well, let's think about the even numbers, right? We know we have 1, 2, 3, 4, 5, 6. These are the numbers on a standard die, right? How many are even? 3, right? So out of this 6, you have a chance to get even 3 times. Okay, so that's taken care of. And then it says, then a number less than 5. So not 5 and less than 5. 1, 2, 3, 4. So we have a 4 out of 6 chance of getting a number less than 5. And all you do is simply times those together. When it's asking, like, you know, pick a card out of the deck, find the probability that I would get a king, then pull a red card. You take it piece by piece. I did this one first, and you would do the king first. And then you look at the other one, which in the one I just said will be red. Here is less than 5. You take those 2 probabilities and times them by each other. And when you do that, you get 1/3. Again, you can do this. Your phone's not going to give you a fraction, but again, I can't stress enough. Desmos, just type in Desmos scientific calculator. So 1/3. Okay. Again, if you don't understand a problem, write the number down, what you don't understand about it, and message me, guys. But I'm hoping this is all coming across pretty clear. Okay, which of these is a statistical question? So let's remember what a statistical question is. It's one where there will be variability in the answer. So the answers will vary for a statistical question. Statistical question, answers vary. So let's look. How far away are you from the school? It's asking about one person, so you're only going to have one answer, right? So I would say that's probably not a statistical question. Think you're probably only going to get one answer. Like right now, how far am I from the school? I'm in the school. So one answer. You would say I'm 30 minutes from the school or 5 minutes. So no variation. How many days are in March? One answer, right? There's only so many days and a set amount of days in March. So that's not a statistical question. How old are the teachers at my school? Well, let's take a look. So let's say Miss Robinson is 33. I am 24. Maynard, let's say he is 27. So the ages are going to be different, right? Because it didn't ask about one specific teacher. It just said teachers at my school. So I'm going to just say that one's a possibility, right? Okay, who is my favorite actor? Okay, who is my favorite actor? Chris Hemsworth. Your favorite actor? I don't even know another actor. Jim Carrey or something. So one answer. So the only answer choice that could possibly be a statistical question and that the answers would vary is how old are the teachers at my school? Okay. Here we're getting into the mean, median, and mode. So let's do this. The mean. The mean, we add the numbers and then divide by the number you added. I don't know how to shorthand write that. I'm just not going to do that. So the mean, let's find the mean of these numbers. So you see my calculator. You see what I'm doing. Okay, so we get this number. Let's count how many numbers we've added. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we need to divide that by 15. 92.4. So we can cross off this one and this one, right? Because these are the only ones that have that. Okay. Let's find, you can find the median, but that is going to require for us to rearrange these terms, right? Because to find the median, you have to rearrange the terms from either least to greatest or greatest to least, and then mark off from the ends until we meet in the middle. Another answer choice that is different is the range. So I'm going to pick the range to see if we can get the right answer. So let's find the highest number in here. I think it's going to be this 153. 153 is the highest. So 153 minus what's the lowest? 27. 126. And we see that's an answer choice. Now, if you wanted to double check, I mean, the modes are the same, so that's not going to help us. You can do the median. Going to require some work. I'm not going to do it for time's sake, but the median would be 85 in this case. Okay. Given the data set below, which is the greatest? Mean, median, mode, or range? Well, the biggest number. It's asking which one has the biggest number. So let's find that. Let's find the mean. And we divide by 10. 27 is the mean. So I'm going to write it out beside here. The median, let's rearrange the numbers. $22, $25, $25, $20. And always count your numbers after you rearrange because you might have missed a number. So rearrange them from least to greatest. Let's mark off. I'm probably going to mark off 4 to start with on each side. Okay, and that actually worked out. So I can't mark off any more because then I won't be in the middle, right? So that means I have two numbers and they're not the same. So when they're not the same, we add them and divide by 2, which is 26. So the median is 26. What's the mode? Remember, the mode is a number that occurs the most. There's only one number that repeats, right? And that's the 25s. So the mode's 25. So right now the mean is looking like it's going to be the answer. Let's find the range. Highest number is 42 minus that low number of 14, 28. So out of these, which one is the greatest, the biggest number? Range. Okay, next question. So far the quarter, I think that in the quarter, I don't know. Samantha's quiz grades in her math class are as follows. And then it lists the grades. If she gets an 89 on her next quiz, which statement is true? Okay. So that means we have to find two sets of data. We need to find it without that next test grade, and then we need to find it with that next test grade. It only asks about the median and the mean in these answer choices, so I'm just going to do the median and the mean for both sets of data. So I'm going to do without that new quiz grade, and then with the new quiz grade. So without the 89, with the 89. Mean, I'm not going to write out median, and then mean, and then median. Okay, so let's find the mean first of without the quiz. So 68 plus 86 plus divide that by 8 because that's how many we added. So 88 is the mean without that new test grade. 88. Let's go ahead and find it with. So we knew before the 89, the total was 704, right? So let's add that 89 in and divide by 9 now, not 8, because we have the new test grade that was added in. So 9 now. And it went up a little bit. Didn't help that much. So this is what I have written down. Without the test grade, it was 88. With the test grade, it went up just a little bit. Okay, let's find the median. I'm going to rearrange the letters with the answer choices so that I don't have to keep referring back to that. So let's write them. I'm going to write them least to greatest. And I know that 89 is going to go there once we add that in. So I'm going to leave a little bit of a blank so I don't have to rewrite the whole thing. Still the same thing. Still going to mark him out the same. Actually, no, I'm not going to do that. 94, 95, 95. Missing a number somewhere. Six, 94, 5, 82. Oh, the 100. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so these are the scores in order from least to greatest without that new 89 test grade. So 1, 2, 3, 1, 2, 3. Can't mark off any more. So they're different numbers. So 86 plus 94 divided by 2. So 90 is the median here. Okay, let's add in where it's supposed to be, that 89. Okay, now let's mark off 3. 3 on this side. Oh, we actually have one middle number here, which is that 89. So let's look at this. What happened? The mean increased with this new one, but that median went down, right? So let's find that. Mean increased and the median decreased. So this is the answer choice, right? The mean, sorry guys, you can't even see that. So comparing the data, the mean increased not by very much, right? But it did increase. And the median went down 1. So the mean increased and the median decreased. Okay. Again, I'm hoping this makes sense. Let me know if it doesn't. The age of each employee at the company is this. Find the mean absolute deviation. Okay, first step, mean. What is the mean? Well, let's find out. Okay, the total number, divide that by 3, 6, 9, 12. So the mean is 36. Now we have to find the difference in between this and every set of data in this and add those together. So 37 minus 22, 15 plus 52 minus 37, 15. I'm going to mark them off as I go. Plus 13. So just the difference. So like the difference between 40 and 37. That's 3, right? You add 3 to that, you get 40. 58 minus 37. And remember, you always do the positive of the number. This is only a 1 difference. This is a 5 difference. 8, 2, 5 plus last one, 12. So let's add all these numbers up. These are the difference in between the mean and each set of numbers. So let's add these together. 15 plus 15 plus 13, 8. Okay, added all the numbers. It should be the same number we divided by, which I think I said was 12. 12. 9. So we added those and divided it by 12, which equals 9. We're going to do the math. So added them, divided by the number we added, which gives us 9. Okay. Honestly, guys, these are my least favorite just because they do require, I feel like, the most work. So again, let's find the mean of these. Well, it says the number of points scored by a football team in each home games is listed below. Find the mean absolute deviation. So find the mean. Divide by the number 3, 6, 7, 8. So the mean's 31. Let's find the difference between 31 and 31, 0. Make sure to always add your 0 in because that's still it counts as a number you need to divide by. 2. I can't do simple math, guys. Don't make fun of me. I like using the calculator as much as I can. 10, 7, and then 1, right? And then once we add that, divide that by 8. So 0 plus 2. So 40, once we add them, we get 40 divided by that 8, 5. 5 should be the answer. And what do we know? The closer to 0 the mean absolute deviation is, the less variety in the numbers. If you take a look, these numbers have a lot less variation in them than these numbers. These numbers go from 22 to 52. These numbers pretty much, other than that 42, kind of stay right in that general area. So that's, see, that deviation is lower than that. So, okay, this says, which data set is least likely to have the least mean absolute deviation? So the less variety in numbers. Okay, let's see. The numbers of books checked out by each person that visits the library on a given day. I can't say that word right now for some reason. Well, Susie checks out 10 every time she goes. I only check out 2. David checks out 20. There's going to be a good bit of deviation in that, right? Everybody checks out a different amount of. I'm going to X that out. I might come back to that. I might not. The ages of students in middle school. In middle school, you're typically somewhere between, I believe, like 12, 13 to like 16. So a little bit of a range. I'm going to put a question mark because y'all are all pretty much going to be, near the same age. The speed of each car on the section of highway. I go above the speed limit. My grandma goes 30 below the speed limit. Probably going to be a variety of different people, right? People fly past, I'm sure, your parents while you're in the vehicle with them, and some people, your mom has to pass them. So I'm going to X that out for sure. I think everyone goes so many different speeds. That one's going to have a lot of variation. The population of each state. We already know that has so much variety, right? Because California and New York, they have way more population. That's obviously why they get, like in the election, they get more like electoral college votes because there's more people there. So definitely not that one. So the only one that I didn't X out and I put a question mark beside is this age of middle school. That's the answer. It's going to be the closest together with each sets of data. Less variety. Okay, a box in which whisker plot, which is asking which correctly displays the data given. Let's look at it. It's not, so we see the lowest number is 2. And we see the highest number is 24. Let's see if we can mark any of them out already. Is there one that the dot isn't on 2 to begin with? Well, this one's not right. It's on 4 or 5-ish, so X that one out. That one is not the answer for sure. This one, it starts on 2, starts on 2. Let's see the last one. These are huge numbers. So I'm just going to go ahead and mark that one out because there's no way that one would even be the answer. So mark it out. So we're only left with these two choices. Let's see if 24. Oh, yeah, they both have the 24. Well, let's see where they're different, right? They're different right around here. So if we can find that middle number, it would let us know whether we need to be on 13, which is this is showing that it's on 13, or do we need to be on this 12? Which one's the middle number? Let's find out. It's already arranged from least to greatest, right? So let's mark out. I'm gonna mark out 4. 1, 2, 3, 4 on each side, and one more. And when I do that, I'm left with 12. So this is on 12, not 13. We can cross that one out. So B would be the answer. Three more questions. Okay. The box and whisker plot below shows the number of students in each of the 12 ninth grade math classes. It says what percentage of the classes have at least 23 students? Okay, so at least 23 students. Here's 23. So it has to have this and it can go on this way, right? At least 23. If it said no more than 23, we would look at it this way, right? But said no more, at least. So we're looking at it this way. Remember, with box and whisker plots, the point of these is to break it up into increments of 25. So this section is 25%. This section, 25%. This section, 25%. And then this last section, 25%. So here's the number 23, and this is where we start looking. So it would be 75%, right? Hope we see that. And again, if it said no more than 23, then we would look this way, and then the answer would be 25, right? All right. Hopefully that makes sense. Okay, this is about biased and unbiased, these last two questions. It says a high school is conducting a survey to see how many students have part-time jobs. Determine whether the sample is biased or unbiased. So if they picked 5 random students in each homeroom, 5 random students, would that be biased or unbiased? Probably unbiased, right? Because you don't determine whether they're guys or girls, whether they get A's or D's, whether they play sports or not. So I would say that's unbiased. And you don't know if they're going to be in 7th grade. Well, I wouldn't say 7th grade having a job. You don't know if they're going to be in 9th grade or 11th grade. So I think that would be unbiased. Let's look at this next question. Same thing about conducting the survey, but they pick, instead of 5 from every homeroom, they do every 10th, that's supposed to say 10th grade student. I'll have to go in and change that. Every 10th grade student that enters the high school or the school football game. So they're not doing it, they're doing it randomly, but they kind of have a set population that they're getting for, right? The 10th grade students. So because they're asking like a specific grade, or even if they were doing every girl that enters the high school football game, you know, there can't be any kind of specific criteria for the participation. So this one is biased because they want the 10th grade. Can't just have a certain grade, right? Or a certain gender or a certain race. It needs to be unbiased, totally random, like the other one where it said 5 people in homeroom. You don't know whether they're going to be in 10th grade, 11th grade, 12th, whether they're always Hispanic, whether they're going to be a boy or a girl. So just keep that in mind. That's it for the review. I hope you guys do good on the test. Again, if you have questions, just message me.